All right, Gaussian elimination. That was when we tried to get this diagonal like this, 1, 0, 0, 0, 1, 0. Or these don't actually have to be 0 up there. We need to get a 1 like this though. And then once we get it to here, that's one of the answers. Okay, let's see if we can't use our calculator to help us with this. So here's the matrix so far. The x is 0, the y is -1, the z is -4, has an answer of -5. X is -2, y is -2, z is 6, answer -2. And -4, -5, 1 with an answer of -16. Okay, so there we have it. And the idea is to get ones coming down here. So I could get, if I could get a row of ones and then a 0, 0, then this is something good. Okay, watch. The calculator can also do that. Let's take a look at what kind this is. Remember DO. We got a down and then an over. So it's down 1, 2, 3, but it's over 1, 2, 3, 4. So this is a 3 by 4 matrix. Okay, let's go put that in the calculator. So I'm going to go to second matrix, edit, and put in 3 by 4. Now you can't hardly get it wrong because see, it makes the table for you to see. I've got 1, 2, 3, 4 numbers got to go across. Well, I need 4 spots, which I have. If you put it in up here wrong, say 4 by 3, see, it's not the, it shows you the wrong size. So you can't really, once you're using your calculator, you almost don't even have to remember down and over is the right order. So I'm going to go 3 by 4 and put in these numbers. So I got a 0 right there, and then a -1, and then a -4, and then that answer is -5. And then we got a -2, and another -2, and a 6, and that answer is -2. And then we had a -4, and a -5, and a 1, and that answer was -16. Okay, so there's our 3 by 4 matrix. Second quit. Now remember where determinant was? It was under matrix math. So if I hit the matrix and the math key and go over to math, determinant was the first one. We'll go down a ways. Gaussian elimination was also called row echelon form, which I'm writing it right up here. It's also called row echelon form. Row echelon form. I think that's how it's spelled. But calculators often just call it REF, for row echelon form. Okay, take your calculator and go down a ways. Look, right there's row echelon form. Okay, well, if we do row echelon form, and I put this in matrix A, I'm going to go second matrix and pull A off of there. The calculator is going to put it in row echelon form for matrix A. Okay, now I don't like that quite as much because I actually like fractions better. So I'm going to hit the math key right here, math, and say fraction. Not that those fractions are any big deal, but usually it's a little bit easier to deal with it as fractions. So there we have it. Okay, so row echelon form, I'm going to write that down over here, is we got 1, 5/4, -1/4, answer 4, 0, 1, 4, 5, 0, 0, 1, 1. Okay, that's what was on the calculator. That's what I have on my calculator. Now the calculator doesn't put this little answer bar, but we know that that answer bar should be there. Okay, Gaussian elimination now. Remember, this was X, this was Y, this was Z, and these were the answers. There's one of them. Z equals 1. Now I can take that and plug it in here. So this is the Y, that's the Z, and that's the answer. So that means 1Y plus 4Z equals 5, and I can stick the 1 in there. So it's Y plus 4 times 1 equals 5. So Y plus 4 equals 5. So Y is also 1. And now this one up here, that's the X. So X, 1X plus 5/4 Y minus 1/4 Z equals 4, and plug them all in. So I've got X plus Okay, y is 1, so that's just going to be 5/4 minus z is 1, so it's going to be 1/4. So 5/4 minus 1/4 is 4/4. So I have x plus 4/4 equals 4. Subtract the 1, and x is 3. So we have an answer set of 311. And our calculator was such a huge help now because it can put these in row echelon form. Now we don't care if they're fractions or not. Let's just do number 14. It's just going to come, it's going to happen really fast now. So this matrix is x is 1, y is 0, z is 2, with an answer of -2. X is -1, y is 2, z is -2 with an answer of -14. X is -5, y is -5, z is 2 with an answer of 4. All I got to do is put that in my calculator, get it in echelon form, and bang. So I'm going to do second matrix. Let's go edit that one. It's a 3×4. You just put it in, so I need a 1, 0, 2, -2, -1, 2, -2, -14, -5, -5, 2, and 4. Okay, second matrix math. Go all the way, it's about number 10 or 11 or 12. It's right there, it's 11. I need the row echelon form of matrix A. Now, this is how come I usually like it as fractions. That's not very nice. So if you go math, fraction, that should clean it up a little bit. Okay, so here's the first one. So I'm going to jot down what we have over here on my paper. So I've got 1, 1, -2 fifths, -4 fifths, 0, 1, -4 fifths, -74 fifteenths, and 0, 0, 1, -23 sixths. Okay, so X, Y, Z, right? Here's one of the answers. So Z is -23 sixths. Over here, I've got 1Y plus -4 fifths Z equals -74 fifteenths. Okay, I'm going to use my calculator for that. So I'm going to add, well, let's see. First, I got to get the 23 sixths in there. So -4 fifths times -4 fifths times -23 sixths. Math fraction is 46 fifteenths. So I have y plus 46 fifteenths equals -74 fifteenths. Well, at least I got a common denominator. I don't really need to do much. I'll subtract -46 fifteenths from both sides. So -74 minus 46. -120 fifteenths. Okay, that will reduce. So we'll take 120 divided by 15 math fraction. Okay, yep. It reduces all right to -8. And here's the last one up there. So 1x plus 1y, which I now know is -8, plus -2 fifths times z equals -4 fifths. Okay, so let's see what this is. -2 fifths times -23 sixths. Math fraction, sorry, is 23 fifteenths. So this piece is positive 23 fifteenths. So I'm going to subtract 23 fifteenths and add 8. So I have -4 fifths I'm going to subtract 23/15 and add 8. Math fraction. 17/3. And that is what that one is. So there's our answer set. X is 17/3. Y was -8 and Z was -23/6. So now even if there's fractions and they're ugly answers, we don't care anymore because our calculator is helping so much. Okay. One of the things that we didn't do very much was Gaussian-Jordan elimination. Gauss says get 1, 0, 0, 0, 1, 0, and then as long as you get this one next, you don't care. You actually don't have to get that one either. You don't care what those are because let's say this is a 7. Here's your first answer set, and then you can just go plug them back in. But Gauss-Jordan says, okay, do it all the way. Get 1, 0, 0, 0, 1, 0, 0, 0, 1. And then let's say we have answers over here of 1, 2, 3. Okay, see, this is the Z answer. Z is 3 because X and Y are both 0. Here, this is the Y answer because Z and X are 0, so this is the Y answer. That would be Y equals 2. And here, Y and Z are gone, so this would be the X answer. That would say X equals 1, Y equals 2, and Z equals 3. See, Jordan says keep going, and if you just keep going and you get the entire diagonal set, 1, 1, 1, and you make everybody else 0, it's a little extra work, then you have the answers. This is the answer to X, this is the answer to Y, and that's the answer to Z. So if you can get this diagonal and everyone else 0, that's the Jordan part, then you just have the answers there. Okay, well, what do you suppose your calculator can do that too? I mean, if it can do this, if it can get 1, 1, 1 with zeros here, why can't it keep going and just get the rest zeros? Well, it can. So let's just put this one in. I'm going to go second matrix, edit, A. Okay, so here's my matrix. X is 3, Y is 0, Z is 2 with an answer of 2. X is 1, Y is 2, Z is 2. Answer -4, X is -3, -5, -5, and 8. So there's the matrix. It's a 3 by 4 again. So 3 by 4, just going to go put all that data in. So I've got a 3, a 0, a 2, a 2, 1, 2, 2, -4, -3, -5, -5, and 8. All right, when you get that in, push pause if you got to get caught up. Second matrix, math. Okay, down here, 11 of them down was REF. If you go one more, RREF. Okay, that's the Gaussian format. That's going to get all diagonals of 1 and everybody else 0. So if I get the super row echelon form, let's see, what does that extra R stand for? I think it's the refined row echelon form of matrix A. Now look how easy it is. So now the calculator did all the work. So here's what that turned out to be: 1, 0, 0, 4, 0, 1, 0, 1, 0, 0, 1, -5. So that means our answers, here's the X answer, X is 4, the Y answer is 1, the Z answer is -5. So we have 4, 1, -5. It really is that simple now with our calculator. Now I know everybody wants to say, how come you just didn't show us that in the first place? Well, somebody has to program all this stuff, so we have to know what's happening, and there's actually going to be some theory classes. If any of you are ever a math major, you have to prove in college why all this stuff works, and if you don't even know how it works, there's no way you can prove that it works. So it's important that you know how it works, but nobody ever does all of this long stuff to make it happen, because now you can just put it in a matrix and get the answers, as long as you know what you're doing with the matrix. So here, number 16, here's our matrix. X is negative 5, Y is 2, Z is 0, answer 6. 1, 5, 4, 5, negative 1, negative 5, 2, negative 2. All you got to do is put it in your calculator, know which buttons to push. If you know which buttons to push, this is really easy. If you don't, well, then it's really long and hard. Negative 5, 2, 0, 6, 1, 5, 4. Okay, there I have them all put in. I'm going to go to second matrix, math. Find row at super row echelon form of matrix A. I guess I could have just done second enter. Okay, so I don't like that, so I'm going to push math, fraction, and get that in a much cleaner format. So there's the x. X is negative 8/9. And just read it off your calculator. Y is 7/9, and Z is 1/2. If we stick X right there and Y right there, it adds up to 6. If we put them X, Y, and Z, it adds up to 5. If we put X, Y, and Z, it adds up to negative 2. Remember how all this started? We started with elimination and substitution and doing all kinds of stuff. Then it went to matrices, and now we're just going to be able to go to our calculator. Okay, let's take a look at the special cases. Sometimes these are undefined, and sometimes they're all solutions. So I'm not going to write all this one down now. I'm just going to go to second matrix and put it in the calculator. It's a 3 by 4. So right here, the x is 6. Y is 6, Z is negative 2, answer negative 8, X negative 5, Y negative 6, Z is 1, answer 13, X negative 6, Y 0, Z 6, answer 6. Okay, so I'm going to go get second matrix math of second matrix A. Okay, so I would like the super row echelon form of matrix A, the Gauss-Jordan elimination. Okay, let's see. I got some fractions there. It's just 2/3. I probably don't have to, but I'm just going to put it into fractions. Okay, see what we have? I'm going to jot down what we have so I can emphasize it. 1, 0, negative 1, 0. 0, 1, 2/3, 0. 0, 0, 0, 1. Okay, it's right here that we have to deal with. See, all of the variables dropped out over here. So this side was 0 and this side is 1. That's false. That's no solutions. So anytime something is false, then it's no solution. So that's one of the special cases. Let's take a look at 18. I'm just going to do the same thing. Let's go to the matrix and put that one in. It's a 3 by 4, so X is 6, Y is 1, Z is negative 3, answer 13. X is 2, Y is 0, Z is negative 1, answer 6. X is 2, Y is negative 1, Z is negative 1, answer 11. Okay, super row echelon form of that one now. Let's see what happens there. See that bottom row? So I'm going to jot it down. I've got 1, 0, negative 1/2, which is 3, 0, 1, 0, negative 5, and then 0, 0, 0, 0. Here they dropped out again. All the variables dropped out again, but now we have 0 on that side and 0 on that side. That's true anytime they drop out, but the solution is true. This is infinite solutions. So that means there's a whole bunch of answers to that one. So there's the two special cases.